Today I will be explaining Pascal's triangle and how it can help you solve distribution problems. So for this problem, I will be using monkeys and bananas as examples. We have our monkeys and M bananas. How many ways do we have to give the monkeys bananas if we give away all of our identical bananas? One way to think of it is with the Pascal's triangle. If you think of it as the top one having 1 monkey and 0 bananas, and for every red arrow increasing the number of monkeys by 1, and for every black lollipop increasing the number of bananas by 1, then you can quickly find out how many ways you have to find a certain amount of monkeys and bananas. For example, let's say 2 monkeys, 3 bananas. Since the top already has 1 monkey, we just need to add 1 more monkey and 3 more bananas, meaning the red arrow, 1 red arrow and 3 black lollipops. Alright, so you can do this in any order you want. In fact, the amount of ways you can do it using different orders is the amount of ways that you can solve this problem, obviously. So, you will come to the number 4 on the 5th line, second from the left. This means that there are 4 ways to solve this problem, because 4 comes from the numbers above it, 1 and 3. The numbers 1 and 3 come from the numbers above it, 1 and 2. The numbers 1 and 2 come from the numbers above it, 1 and 1, which both come from the top number 1. This means that whichever number is on the Pascal's triangle is the number of ways you can distribute the amount of monkeys and bananas to get to that place. For example, if you go down to the very bottom and go for eight monkeys. For example, if you decide to try and get to the left 35, there will be 35 ways to get to that number. And if you try to get to the right 35, there will be 35 different ways to get to that number. Another way of thinking is algebraically. So on the right, I have a table with the number of monkeys and the number of bananas. Are you noticing anything strange about this table? If you turn the table 45 degrees to its right, then you'll be able to see that it's in fact the same as Pascal's triangle. So the number of monkeys is which column of Pascal's triangle it will be on, and the number of bananas is which row of it. Now let's solve a simple problem. 2 monkeys, 2 bananas. Since the top is 1 monkey, 0 bananas, we need to add 1 monkey and 2 bananas to find 2 monkeys, 2 bananas. In other words, add a red arrow and then add 2 black arrows. You'll get to the left 3 on the 4th row if you do it right, which means there are 3 ways to get to that place. In conclusion, Pascal's triangle is a geometric solution to the problem of distributing something, for example bananas, among people, for example monkeys. It can help us find out the number of ways to distribute something easily, making it extremely important.